Alright, John here, and we are going to move on to Project Euler number 3 about the largest prime factor. So, we have a number that comes in, and we want to figure out the prime factors of that number, and then pick the biggest one of those. So, let's work through this. Okay, so I thought about this, and my strategy is going to be to start from 2 and just start walking numbers up, so incrementing from 2 and testing whether we're dividing evenly the target number by our incremented number. And then if we find a match, then we know that that is a prime factor. Then we can divide the number by that factor, and then we'll have a new number that we'll try to factor again, and then basically that result will keep getting smaller and smaller, and we can kind of recursively shrink that number down until it can't be divided by anything, and then we're done, right? Then we'll have all our prime factors, and we can just pick the biggest one. Okay, so let's start by defining a find factor function. Okay, so we have define find factor. It's going to take one argument in, and what we're going to do with that is we're going to do a series of operations. So the first thing we want to do is we want to do a range on that number, and we're going to start with 2 and go up to, we actually want to go to n plus 1, right? Because say for the case of 3, then 3 is the largest prime factor, so we can't just stop at 2, we need to actually go to 3. So we'll have the range from 2 to n, and then what we want to do is we want to, well, let's just evaluate that and see what we get there. So we have our find factor function. Let me make this a little bigger here. Okay, so we have our find factor function there, and let's put in our test case find factor, and it was 13195. So if we evaluate with our function, then we get this big series of numbers all the way up. So what we want to do is we want to find the first in this series of numbers that is evenly divisible. So what we want to do is we want to do the drop while with a predicate, and our predicate is going to be that the remainder is not 0. Okay, so not equal 0, remainder of, we're going to divide our number, our input number, by the current value in our range here. Okay, so now we should get rid of all the non-prime factors up to the first one. Let's try that out. Oops, we are missing our anonymous function symbol here. Okay, so we got that defined. Okay, so now we dropped off 2, 3, and 4 because they were not factors, so now we have the first prime factor, and then the rest of the numbers up to the number. So from that, we just want to get the first from that. sequence. So now we can try that, let's evaluate that and test it out. Okay, so now we got 5. So now we have a function that will give us the next prime factor. Okay, so let's go ahead and make our function that factorializes here. Let's call it fact. It's going to take in an one value here. Okay, so what we want to do is we're going to loop and recur. So let's bind our variables. We're going to start with in, and it's going to be initialized with in. And then what we're going to do is we're going to build up our set of factors, and we're just going to do a Clojure set so that if we have any duplicates, then we don't care. It won't matter. Okay, so we're going to loop, and then we will recur later. So, okay, we're going to loop recur. Let's start with our base case. So our base case is that is if our find factor returns nil, right? If we did eventually, find factor 7, it gives 7, and then if we try to run it, so once we run on it and we divide that, we divide 7 by 7, and we're going to end up with 1. We run that again, and then eventually we're going to get down to nil. So if nil in, then that's our base case, we're done. So we want to return our factor set. Okay, otherwise, then we want to do our recursion. That's our else case. Okay, so let's just do this. We're gonna find the next value from in, find next in. Alright, and that will be next. Okay, and then the other thing we need to do is we need to find the quotient. Just do, let's call it Q. Find the quotient. And we're going to divide in by the next value that we find. And that will go in the quotient. We need to be careful here because n can be nil. So we're going to do if nil next. Then just, I'll set Q to be nil. Otherwise, we're going to do our division. Let's see if, close that out. Okay. So if next is not nil, then we'll do our division. Otherwise, we put nil in Q. Okay. So now we have our next and our Q defined. So when we recur, we need to recur on Q will be our new smaller value that we're going to take in. And then we need to put our next value into our quotient set, or our factor set, sorry. So we will conj onto factors next. parentheses here. Okay, so we loop, test our base case, we find the next value, or division. Okay, I think that looks correct. Well, find next, oops, sorry. Find factor is what we called it. Let's try that. Find factor, okay. So, let's try to run that. We run factor of 1. I'll start higher. 3. Q mark cannot be cast to a number. Let's debug that real quick. If nil factors let, okay, find factor n. Next, if nil, oh, here we go. There's our mistake right there, question mark. We want to return nil, not the function. Let's try that again. Okay, factorial 3. Okay, there we go. We got nil and 3, so we have sort of an extra nil in there in our set. So we'll have to deal with that. So let's try. Their test case was 1, 3, 1, 9, 5. There we go. 7, 13, 20. 9 and 5. Okay, yeah, so that matches up except for our extra nil. So we can do a Clojure dot set difference, and that will just subtract off a set with nil. That gets rid of our nil. And so let's just make a function factorialize. It takes a parameter in, runs it, and drops off the extra nil. We can do our factorialize 13195, run that. There we go. So now if we sort that, now we have 5, 7, 13, 29, and well, let's do that here. Sort and last. We want to get the last from there. So now, okay, define that function, execute it, and we get 29. Okay, so it looks good. So I think we have our function there. You know, we could tidy this up with our threading macro again. But yeah, that's fine. It's relatively small. We'll just leave it as is. So it's kind of a nested thing. It's not too pretty, but that's okay for now. So we factorize that. We get the answer 29 which looks right. So now let's try out the final test. 6008514751443. 6008 514751443. Okay, let's test that out. 6857 93526. All right, let's check it out. Hey, we got another one right. Good, thanks for watching.